Hello friends, welcome to I am Novice Civil Engineer, and today I am going to teach you about how we can analyze this simple frame in STAAD Pro where A is fixed and C and D are hinged, and we have 1 kN acting at 2 meter distance from A and 20 kN per meter UDL and then 20 kN of a point load at a distance of 2 meters from A. So now we are going to first open STAAD Pro and then we are going to analyze it. So now we have opened STAAD and then we are going to select space and then name of the file, it is ABC, and my units will be in meter and kilonewton, and then next add the. Now this is my STAAD grid. I'm going to select front view and then I'm going to extend my grid up to my requirement. My grid will require 4 plus 4 plus 2 10, so this is 10 meters, so I don't have to extend my grid in horizontal direction, and in vertical I need only 4 meters. So in vertical direction also I don't need to extend my grid. After that, first we will add a node. We will have a node at A, B, C and D. So first I will make B, at coordinate 0, 4 we will make A, and then I'll go to 6 meter to B and another 4 meter to C, and then now I'll go from B to D as 4 meters. So first at 4 meter I will go, then at 6 I will have a node, then at 10 I will have a node, and I will have another node, another beam from this point to 6 at x-axis. That's it. My beam has been made. I will turn on my grid off from snap node slash beam. Now my grid has turned off, and now I will turn on the labels of node numbers and grid numbers. You can turn on the labels from view and then structural diagram, then labels, then node, and then node number and beam number. Select apply and then OK. Now this is my beams. This is my point A, B, C and D. This is my point A, B, C and D. So first we are going to assign the properties of the beam. So I'll go on journal, property, define. Now I will have 0.02 meters, the dia of my beam. So 0.02 meter into 1000. So I will have 20 mm, that is 2 centimeter dia grid, dia beam, then add it and then close it. So for after that I'll assign this 0.02 meter dia circular steel beam to my members, member 1, member 2 and then member 3. After that I'm going to assign supports. So I'll click on support, I'll create. So I need two supports, one is fixed and another one is pinned. So I'll add a fixed support, then I will add pinned support. After that I have fixed support at A and pinned at C and D. So I will assign the fixed support at node 1 and pinned support at 3 and 4. So my supports are assigned. Now I need to assign my loads. So I'll go on loads and definitions. I have 2 point loads and then 1 UDL. So I'll go to load case detail, add. This will be a live load. So first in the question we are not asked about calculating the dead load, but we will assign dead load also. So first I'm going to assign dead load and it is DA dead, DEAD dead. After that we are going to assign live load as UDL, then another live load at point load 1 and then another one is point load 2, add, and then I'll apply a load combination with safety factor as 1.5. So I'll go on define combination, then give safety combination AI value as 1.5, and then I will assign all the load cases, add it, close it. So I have a combination load case. I have a dead load, UDL, point load 1 and point load 2. So in dead load, I will click on dead load and then add, then y, and the factor is -1 because it is acting downward in y direction. So add it, close it. So this question mark is coming, that means this load is not assigned to the member. So I'll click on the load and then assign it, and then I'll go and assign to view because I need to assign the dead load to all the components. So I'll go and assign to view and then assign it. Automatically it will be assigned to all the beam members. After that I'll go on UDL, add it, and then go to member load, click save. So my UDL is 20 kilonewton per meter acting downwards from B to C. So my UDL will be -20 kilonewton meter per meter, and then I'll go from, I'll select global Y, add it, close it. Now question mark is coming, that means it is not assigned. Click on it. Now don't click on assign to view. If you click on assign to view, then it will assign to all the beams. So we'll click on assign, use cursor to assign, and then assign it to the beam B. After that we have point load 1, which is a 120 kilonewton point load acting at 2 meter from A. So to assign the load, we need to assign a node first. So I'll click on beam 1, I'll go right click on it, I'll click on insert node. So my distance is 2 meters from A, so I will assign it as 2 meters, add a new point. Okay. So you can see this node 5 has been assigned. We can check the direction also. From 1, 5, it's 2 meter. So I'm first going to define point load. So my point load is 120 kilonewton. So I'll click on add, I'll click on nodal load, then bidirection -120 because it is acting downward, add, close it, and then go click on this load, click on this load, click on assign, and then assign it at load at node 5. Now go to point load 2, click on add. Now we have point load acting in X direction, which is positive X direction of 20 kilonewton. So firstly we need to assign the node. So before assigning the load, so it is acting 2 meters or the midpoint of this beam BD, sorry. It is acting on the midpoint, so we will select this beam, we'll right click on it, we'll go to insert node and then add at midpoint. It will automatically assign the node at the midpoint, select OK. So the node 6 has been assigned at the midpoint. Click on point load 2, add, go to the nodal load, and it is 20 kilonewton, which is acting in positive S direction. So 20 kilonewton, add it, close it, click on it, assign, and then assign it to node 6. So my loads has been assigned. This is so you know that I have created these nodes after assigning the self feed. So my self feed is not assigned to these two beams. So I'll click on it. Either I can go to use cursor to assign or assign to selected beams, or I can go on assign to the view, but assign to the view, assign it. So 1 to 5, 1, 2, 3, 4. So all the beams are assigned. 1, 2. This is 2 beams. 3, 4, 5. All the beams are assigned. This is my UDA. This is my point load. This is my point load second. And this is my combination of all the load case. So after that, I have assigned the support, I have assigned the property, I have assigned the load. So my problem is finished. Now I just need to analyze it. So go on analyze and print, add it, close it, and then go to analyze and analysis. Okay, so this is my post processing. This is my deflection data. The deflection is quite high. Because of dead load, there is very less deflection. Because of UDL, there is a lot of deflection is going on. This is point load deflection. This combination with safety factor as 1.5. you can go to reactions to check the reaction for different load cases. We go for combination load case. This is reaction, and then this is bending moment diagram. If we will click on F1Y, then we will get the shear force diagram in Y direction, and if you click Z, then you will get shear force diagram in Z direction. So this is my bending moment diagram, shear force diagram. You can get it by clicking on Fy, and this is my bending moment diagram. You can get it by clicking on MZ. So this is, I click on animations, I go to deflection animations, apply it, close it. So this is my deflection animation of the beam. So our modeling and post processing is done, and our problem has been analyzed through STAAD Pro V8i. Thanks for watching this video. Have a great day. Thank you.